Started.
Okay, thank you so much. A very good evening to everybody. And for those that are joining us for the first time, my name is Namazavo Kone. We will be doing Unit 4 today, which is integrals of hyperbolic functions. As you may have realized, hyperbolic functions are actually very closely related to trig functions. And they've got identities similar to those of trig functions, but there are some varieties here and there. So that is why today I want us to first have a look at the identities and the definitions of hyperbolic functions, because sometimes people may think that they are exactly the same as trig functions, but there are some very minor varieties here and there. So the first slide, which is going to follow now, I don't know what I pressed. I want it to go on, and it's not. So, there you go. Before that slide, one thing that I need to emphasize, as we used to do every time, the identity, the integration rules number 2 and 3. You will see until we finish that those integration rules apply almost everywhere. Even here in hyperbolic functions, we will see a lot of them. Whenever we cannot do integration for a particular hyperbolic function, we will be able to do integration using rule number either 2 or 3, which are the rules that is there anyone else who, because you are not presenters, you cannot admit. So I will do the admission of those that are popping in now. But now the first rule, which is rule number 2, is the one that we always explain first, which is having a red derivative there. That red derivative just have to be there so that integration can happen on a function of x. Normally, integration happens on a variable x, which is raised to the power n, and you just take 1 and you add it onto the exponent and you divide by the result. But for you to do the same thing on a function of x, now when you check the right-hand side, that red part is not there anymore because it is just there as a facilitator to facilitate the integration process to take place. When n is equals to -1, we get a problem of dividing by a 0 on the right-hand side. So to avoid that problem, the rule has been established that whenever that happens, the integral will be the integral of ln of the function f of x. Now, those rules that I was talking about are the ones that are on your screen now. Now, on the left-hand side are just the definitions. Now, the definitions are of the 3 basic hyperbolic functions, but they are inverse, not inverse, but reciprocal identities for each one of these 3. The first one is sin of x, which has got its reciprocal 1 over cosec of x. So which means that the definition for cosec of x will be 2 over e to the power of x minus e to the power of minus x. And the same will apply to cos x and sec x. So which means sec x will be equals to 2 over e to the power of x plus e to the power of minus x. Tan of x is given here as e to the power of x minus e to the power of minus x all over e to the power of x plus e to the power of minus x. And this is coming from the basic definition of tan, which is equivalent to the identity cos over sine. In this case, it will be cos over sin. And then if you can look at the one that we have above there, and you divide them accordingly to have the one for sin on top and divided by the one for cos at the bottom, the 2's will cancel out and you'll eventually have what you see there at the bottom of your screen. Then it means that cot, which is cot with an H, will be a reciprocal of the last one that you see there. So which means that cos of x will be equal to e to the power of x plus e to the power of minus x all over e to the power of x minus e to the power of minus x. Then on the right-hand side are our identities. Now, these are the ones that you need to be very careful about because they usually resemble the trig identities, but you will find that here and there are differences, especially in signs. Like the first one. Now, in the first one, you can see that under the trigonometric identities, we get cos squared x plus sine squared x equal to 1. But here we've got cos squared x minus sin squared x is equals to 1. So the difference is that minus sign in between. But in the trig ones, then they are adding each other out. And then the sum is equals to 1 of the squares. And also the follow there, you just need to be careful about their signs as well, because they are not exactly the same. Not all of them are exactly the same way they do as in trigonometry. And then the compound rules as well. If you go down there, you will realize that there is a compound rule that expands sin of 2x, which is similar to the one for sine 2x. And then the ones for the three versions for cos are there, those that you can see there. And you can realize that the first one, under normal circumstances in trig, we will have cos 2x equals to cos squared x minus sine squared x. But here it's a plus in between. Those are the things that I was talking about when I said you need to be very, very careful about these things. So our first activity will be this one. As I have said at the beginning, today I don't think that it would be beneficial for you to just see me explaining and showing you how to do these things, because these are very closely related to trig functions. So I would like you guys to come and do this one until you finish, and let me know when you are done so that we can go with this together step by step. So can you please do this, and whoever finishes first, let us know, and then we can start discussing. Thank you so much. I will give you, say, 2-3 minutes for you to do this because it's easy. Let's start now. And then whenever you are done, just shout. You don't have to raise up your hand. Just start talking and say, I'm done. And I'll be counting down. If you remember in the previous lessons, I have mentioned this statement, which is very, very important. I will mention it again. For you to be able to master integration, you must be on top of your differentiation, because there is no way in which you can be able to do integration without understanding your derivatives. So those are the key things that you need to have. Derivatives first. Then this one will just come naturally. Do you have anyone with the final answer? We don't want you for now to explain the steps. Just give us the final answer. And for those that are just sitting and waiting for us to do the solutions, I will tell you one thing about maths. Maths has nothing to do with your intelligence. Maths is always about hard work. Maths is about things that you are supposed to do. Maths is like driving a car. If you are sitting in front of on the front seat of any car, and you are watching a person driving the car, the day that you are asked to go and sit and drive, you will see that it is not as easy as what you see. Same applies to maths. So if you just watch us doing your examples for you and just believe that you are understanding, just try to do it on your own. You will see how hard it is, which is why I'm saying let's do it and get an answer first, so that when we do and you the solution and you realize where you have made mistakes, that is when you are learning properly. But if you just sit here and you are watching and you think, now that I have watched, now I am able to do it, that's not the case. Anyone with a final answer, please? We've got a lot of examples to go through today. Or is it that difficult that nobody is able to get it? 3 minutes is gone. Can I get a 1% just tell me if you guys are unable to do it so that we can do it together?
I'd like to give it a try, sir.
You are still trying?
No, I'd like to give the answer a try.
Oh yeah, yes. And another thing before you give your answer, there is no wrong answer that we are going to get from anyone. Whatever answer that you give, it's correct until we prove it wrong. So please do not be afraid to give an answer that you feel is wrong, because now it is the way in which we will explain when yours is wrong, and then you will have that aha moment when you see your mistake. Go ahead and give us the answer.
Okay, sir. So the answer that I got is ln of 5 plus sin h 3x all over 3 plus c.
So which is the same as 1 over 3
Ln
ln
into
into
yes,
5 plus sin 3x close bracket plus c.
yes, sir.
Right. So is there any other person who has got a different answer to this one? Because we are allowed to have different opinions. We are not saying the answer that was given is right or wrong. We are saying if you have done it and you have got an answer that does not look like what we just mentioned there, what he is saying is that the answer is ln of open bracket 5 plus sin of 3x close bracket all over 3 plus c. So let's verify if now that answer is correct. And we will hope that everybody else has tried and they've got their answers. If it is the same, then it means that we will be happy that the answer is correct if it's the same. But if it's different from what we will see here, then we will see where we have gone wrong. Now, the first important thing, as I have been saying, is to know your derivatives. This is the key to solving this question. The fact that the derivative of sin of f of x is found by finding the derivative of f of x multiplied by cosh of f of x. That's how you do that derivative. So which means the derivative of 5 plus sin of 3x will be 3 sin of 3x. So because of that fact, then it means that here we will go and apply rule number 3. If you remember rule number 3 will have an fx at the bottom and a derivative of fx on top. And then it becomes ln of the one that is at the bottom. Now let's see now how we can make this question to be ready for us to be able to apply rule number 3. We do this by identifying now the derivative. Now, as we said, the derivative will be 3 cosh. Now, that is where the 1 over 3 that you see outside is coming from. That 1 over 3 is coming to compensate for the 3 that we needed inside there for it to for us to have a complete derivative of sin of 3x. Now, what you see there in red is that derivative that we need that will act as just a facilitator for us to be able to take what is inside the bracket s f of x, and we apply the rule number 3. And you can see that the power is minus 1, so we cannot apply rule number 2. So we're supposed to do that one of Lin, and in actual fact get exactly the answer that was given by one of you guys. And I hope the rest of you has got the same answer. If not, you have seen where you have gone wrong. Let's now do the same with this one. The integral of 6 tan of 3x plus sin of 3x, all of this divided by cosh 3x dx. Can you please do this one and give us the answer as soon as you get it? Final answer when you, as soon as you're done. Please just switch on your mic and give us the final answer. Anyone with something?
About to finish, sir.
Okay. Finish up and let us know what the final answer is.
Yes, I think I can give you my answer.
Please do.
6 cos 3x plus ln cos 3x plus c.
6 cosh.
Cos 3x, yes.
6 cosh. Okay.
Plus ln
And then
cos.
ln cosh 3x.
Yes, sir. Plus c.
Do you have an alternative answer?
Yes, maybe I can try.
Please do.
Yeah, minus 2 such 3x
Minus 2
plus
sech 3x
1 over 3 ln open bracket cosh 3x close bracket plus c.
Okay, so it's a little bit different from the one that we had. Let's get the third one if anybody has got a different one from the other two, please. So that we can work with 3 possibilities. Or you have got only those 2?
Yes, me say I got the last guy that just said it, the last answer. I got the same.
Or so it's the same. Oh, okay. So let's see how I did it, and we'll check if any one of the 2 is correct. So firstly, when we look at this thing, we will ask ourselves, is there anywhere maybe we can say the top one, the top part, which looks more difficult? Can we find its derivative and connect it to 1 over cosh? The answer is no, because it contains both tan and sin. If maybe it was only sin over cos, then we could talk about something like that, or using our identities to make it a single identity. But with this case, then there is no other plan except to first divide each one of the numerators by cosh 3x separately. So what we are going to do is to try and divide each one of the ones in the numerator by cosh 3x. And I am okay. Then when we do that, the left hand side, which is the 6 times 3x, we just take the cosh 3x up. 1 over cosh is actually such 3x. Then we eventually get minus 6 such 3x times 3x. The times 3x is the one that was there already. So the other one, when we divide sin 3x and cosh 3x, we get an identity tan 3x. So we've got that tan 3x that comes out of the fraction sin 3x over cosh 3x. Now we need now to try and now go and look at our given integrals that are on the information booklet there. And when we go there, we find that for the first term that we have there, we indeed have an integral of such 3x times 3x. It's there. So it's just for us to be able to write it properly so that it is accompanied by the derivative of the 3x. And we also look at tan 3x as it is, and we realize that indeed tan 3x does have an integral that is there in the list as well. It just needs to be accompanied by the derivative of 3x. So then we prepare our integrals so that they sit exactly in the same way as what we see in the information booklet. And the preparation goes like this. We are going to look at these rules in our information sheet, rule number 18 and rule number 22. And we make these values that are inside the bracket to resemble those rules. And this is how they look like. So what happened with the first term is that because we've got a 6 already there, but we only need a 3, we factor out a 2 and we put it outside. If we take that 2 and we multiply it inside, take that 2, multiply it inside, you get back to what we had before. And on the tan 3x, what we need is a 3. That 3 is not there, so we bring it, that the one in red, and we compensate for that by multiplying it by its reciprocal 1 over 3, so that we don't change these two things so that they remain equal. Now, this is ready for us to copy from rule number 18 and rule number 22. When you go to rule number 18, you realize that the integral of f prime x such f of x tan f of x is given as minus such of f of x, which is this one that we have. That is where we get this negative sign. The 2 that was there outside is the one that you see there. And for tan 3x, it becomes of cosh 3x. Now, in this one, which is lean, even if we didn't do this issue of tan 3x, and we wrote this 2 as sine 3x over cosh 3x, then it's just a matter of connecting this cosh 3x with its derivative. What is the derivative of cosh 3x? It is 3 sin 3x sitting there on top. Now, when 3 sin 3x is sitting on top is as a derivative of cosh, then it means that we apply rule number 3 and we get it as ln of cosh 3x, which is this one. But there is no need for that because the integral of tan 3x is there and you read it directly from the information booklet. And this is how the answer is. And whoever gave us an answer that is not consistent with what we have here, I hope you have seen where you made your mistake.
Sir,
Yes.
there, I believe it's plus 1 over 3 ln cos 3x.
You mean here, ne?
Yes, sir.
Absolutely. I forgot to write this 1 over 3. You are 100% correct. So let me just correct it right away. So here, I forgot the 1 over 3 that was outside. And now it's in. And we can now continue from here. I'm just saving this change. And that you are absolutely right. And that is the case. There you go. So now let's move to the next one. And the next one looks like this. It is the integral of sin, the integral dx over sin squared of x multiplied by the square root of 5 minus cos x. Can you please attempt this one? And then we will have a look at it after you give us the final answer. Anyone with an possible answer?
I got an answer, sir.
Let's hear the answer.
I got minus 2 cosec x plus c.
Minus 2 cosec x plus c.
Plus c.
Okay, thank you so much. Let's get somebody else if there's anybody who is getting something different. No right or wrong answer until we prove it otherwise. So whatever you are getting is correct for now. So let's share it. Or are you all agreeing with the one that was given? As I have mentioned at the beginning, mastering integration has everything to do with you mastering derivatives. Now, if you look at this question, whatever is inside this square root sign is your candidate of being f of x. And if you find the derivative of this, and you are able to connect it with 1 over sin squared x, then your job is done. That is why the first thing that you need to go to is the derivatives. And you check what is the derivative of cos of f of x. And you find that the derivative of cos of f of x is minus the derivative of f of x multiplied by cosec squared of f of x. And if you check the 1 over sin squared x that you have there, that is exactly the same as cosec squared, which means that your derivative is almost done. And because your f of x is x, the derivative of x is 1, so there's not even a need for putting any other thing extra. What you only need to do is to just check how rule number 2 works, and then go and rewrite this as rule number 2 dictates. Rule number 2 is the first rule that I have shown in the first slide, that when I said that these are the 2 rules that will be governing us all the time. You can see now here we have got a derivative that is sitting there in red. You have got your f of x inside the bracket, which is 5 minus cos of x. And we know that the derivative of minus cos of x will be positive now, because the derivative of a positive cos is negative. Then the derivative of this will be negative times this negative, then that is why here it is positive. So you have got its derivative, f of x is here, its derivative is there, n is equals to your half, then you just add 1 and divide by the result. And you get an answer that looks like that, which is 2 square root of 5 minus cos of x, all of this plus c. Where does this 2 come from? Now you will remember that when you add 1 to this minus half, you get half. Then you must divide by that result. At the end, you must say the 5 minus cos x power half all over half. And dividing by half is the same as multiplying by 2. And then that is where you get this. And this is the integral of what is given there. Let's try this one. Let's try this one. And as soon as you are done, please let us know.
Excuse me, sir. I think I've got an answer.
Please come with the answer.
I think it might be 1.
1.
If I understand correctly, sir, I think so.
So the integral of this is just 1.
That's what it appears to be, sir.
Okay. Let's hold on to that answer, 1. I'm trying to imagine what was there just before the 1. But it's fine. Let's just wait for other options. Is there any other person who has got a different answer from 1? Other guys, come on. If you are waiting for the solutions, you could have just even stopped attending and waited for this this document to be emailed to you, and you go through the document. Here we are supposed to try and fail and wake up, fall and wake up and try again. So we cannot just sit and watch, please. Let's get answers. I
So
hope this, yes, come with it.
I was just double checking, but I think it's ln cosh x plus c.
Ln cosh x plus c. So we've got 2 answers. Another one is 1. Another one is ln cosh of x plus c.
I second the second answer.
You are seconding the second answer, ln cosh of x plus c.
Yes.
Thank you. Now, if there's no other, is there anyone who has got an objection with any of the 2 previous answers given? So in democracy, we cannot just give secondments only. We must also give opportunity for the opposing voice. Anyone who is contrary to what we have? No one. So let's do it. Now, if you remember, for those of you who attended the trig integrals, I mentioned, in fact, it is not only the trig, I think I mentioned it even before. Whenever you are dealing with integrals, wherever you find ln, there is no integral of a ln itself. As if you can go and check in your information book, you will find the integrals listed there. There is no one that you will find which is integral of ln of f of x. So whenever you find ln is in your integral, take the ln together with whatever it is having as your f of x all the time. So here, your f of x is ln cosh of x, and then find its derivative. So you do what I just did there on top. Let f of x be equals to ln. Ln must be part of your f of x all the time. You cannot take f of x as cosh x because you will not have ln of that integral. So now that we have got our f of x as ln cosh of x, we find its derivative. And the derivative of ln cosh of x is actually the derivative of cosh x. And if you can go and check in derivatives, the derivative of cosh x is different from the derivative of trig function cos x, because the derivative of cos x is minus sine x. But with hyperbolic functions, the derivative of cosh is exactly sine as it is. It's not minus sine. So that is why you have your ln cosh x, its derivative being sin x over cosh x. And what does sin x over cosh x according to identities represent? That is exactly tan x, which we have up there. So which means that this question itself is ready for it to be integrated using rule number 3. If you remember rule number 3, rule number 3 goes like this. It says, if the derivative of a function x is sitting there on top and at the bottom is the function f of x. Now I just wrote it up here and have a power of -1, which is exactly the same as what we have there. So it means that this is just exactly rule number 3. And the only key for you to be able to realize this is for you to be able to understand derivatives, which is what we have on the right side here. Because if you don't understand derivatives, there's no way you can be able to see that the whole of ln cosh x is your f of x, which means the correct answer to this question is ln of ln cosh x plus c. Do you agree with me? Especially those that have given the answer as ln cosh x plus c only. There's to be 2 lns here. Are we all together?
Noted. Yes.
Okay, perfect. So that's how we do this one. Now let's go to this one. I must say up front here that there is a method that we will deal with later, where we have a situation like this where we have 2 functions of x that are not related, and we're supposed to find the integral. There's a method that is used, which in this case we are not going to use because there's an easier way of solving this problem. There will be situations where there's no other way except using that method called integration by parts. I hope you have done it in first year. If not, don't worry, we will do it. I will explain how it works and when you apply it. It is applied to questions similar to this one. But with this one, there's a short method that we can use to be able to solve this one. So maybe as a hint, you may go and revisit your identities. Then you may be able to see what I'm talking about. Let's hear the answers. Any answers?
So the first answer is negative half times e to the power x plus 1 over 6 times e to the power negative 3x plus c.
Half e to the power of x plus 1 over 6 e to the power of minus x, which can be written as which can be written actually as 1 over 6 e to the power of x when you want to write everything with positive exponents. Can you repeat your answer again, please?
It's negative 1 over 3. Negative 1 over 2 times e to the power x plus 1 over 6 times e to the power negative 3x plus c.
Or e to the power minus 3x?
Yes, sir.
Okay. All right. That's this your possible answers, ladies and gentlemen. So do we have any other one with a different correct answer? Any other? So are we all agreeing with that? So the hint here that I gave you is that you must go look at identities so that you can replace sin of x with its exponential equivalent, which is what you see on the right hand corner of your screen. Then if you go and replace sin x with this, you end up having something like that. Now this half is coming from the 2 that you see here, because this 2 has nothing to do with these values. I took it out because it's a constant, and that is where this half is coming from. This numerator is the numerator that is there, and this e to the power of 2x is the one that you have right there. Then we just divide each one of these two terms with e to the power of 2x, so that we get the half integral of e to the power of minus x minus e to the power of minus 3x. This first one is found by dividing e to the power of x by e to the power of 2x, because this 2x, when it goes up, the power will become negative, and then we will have x minus 2x, which gives us the minus x, which is this one. Minus x minus 2x gives us the minus 3x. But now if you go to first year integrals, you will realize that for you to be able to integrate any e to the power of f of x, that e to the power of f of x must be accompanied by the derivative of f of x. So if you find the derivative of the exponent here is minus 1, the derivative of the exponent here is minus 3. So for you to be able to do integration properly, you need to have these integrals looking like that. Now, when you have the derivatives sitting here, then the integral of e to the power of x remains as it is. If this is the derivative of what is there and the exponent, then the integral of e to the power of minus 3x remains exactly as it is. That is why you have that, which is minus half. And this negative half came because we needed a minus 1 to sit here. Now, when you need a minus 1 to sit here, you must compensate with another minus 1 outside, so that this negative outside times the negative inside will become positive 1. So that is where we get this negative from. This minus half is the one that was outside, which is this one. And e to the power of x is the same as it is there, because it was accompanied by its derivative. Same applies to this one. 1 over 6 is the one that you see here. E to the power of 3x is the integral of e to the power of minus 3x, because this is the derivative of the exponent that sits there on top. So I think the previous speaker just missed a minus sign here, if I'm not mistaken. The rest is 100% correct. But now, I don't know how strict Dr. Dlamini is about negative exponents, but we always preach that always give your final answers with positive exponents, which means if that is a requirement in your course, you need to rewrite the answers like you see there on the screen as minus 1 over 2 e to the power of x plus 1 over 6 e to the power of 3x. All of this plus c. That's how we do this one. And let's try this one. And we had, I think, a similar kind of question like this in trigonometry. And I hope you can be able to sort this one out. Please do this one. Any answers so far? Sin power of 3 of 2x. Now, what we had at the beginning, those identities only contained powers of 2. There was no power of 3. So that is what you need to bear in mind. So if you cannot have the powers of 2, how can you create a situation where they appear when you have got a power of 3? What would you do? If you have got the answer to that, it gives you a step away from preparing for rule number 3. Anyone with a final answer? Any answers?
Yes, sir. It's 1 over 6 cos cubed 2x minus half cos 2x plus c.
Cos cubed and the other one minus cos.
Yes, 1 over 6 cos cubed 2x
2x
minus
is
1 over 2 cos 2x plus c.
okay. I got it. Thank you so much. Any other one with an opposing view, or anyone who is seconding this one? Anyone with an alternative solution? Okay, let's see if that one that we just had is the same as what we have here. Right, the first thing will be to split this into two. One will be sin of 2x, the other one will be sin squared. And we know that with sin squared, we've got identities. And now the identity that we will use here will be the one that you see on the top right of your screen, cos squared, x minus sin squared, x equals to 1. So because we have on our integral sin squared, we will make it the subject of the formula. So we'll move sin squared x to the right and 1 to the left. Then we replace sin squared with that in the next step, which gives us cos squared 2x minus 1. All of this multiplied by sin 2x dx. Then we separate these two integrals. And when we separate them, we will write them in such a manner that they will resemble some of the rules that we know. And if you check now the step that we have, which has got red things on it, the first integral has got 2 sin 2x. This 2 that we have brought here is brought there because the derivative of cos 2x is 2 sin 2x. That's why there is this 2. We compensate it with the half that is outside, and then this resembles rule number 2 in our integrals. Now, the other term is just the integral of sin 2x. It's there on the list, but when you go to the list, you will realize that it says the integral of f prime of x, which is the derivative of the function of x. The function of x in this case is 2x, and its derivative is 2. That's why you see the red 2 that is there. Then from there, it's just a matter of going to individual rules. Rule number 2 for the first term, rule number 16 for the second term, and you get the answer exactly as the previous speaker said. 1 over 6 cos 3 2x cos power 3 3x, and 1 over 6 came about because we said this 2 plus 1 divided by the result. So 2 plus 1 is the power 3 that you have here divided by 3, but this 1 over 3 is finding a half there. So half times 1 over 3 is 1 over 6, which is the first number that you see there. This minus half is the one that you see here. The integral of that is cos 2x, and we are done. Now, what about when our power is even, like this one, cos power 4 of x? Can you please try this one? So we've already realized that when the power is odd, you just take away 1 and leave the power that is even. If the power is even and it is 2, it's much easier. If the power that is even it's 4 and you have got a separate function there, then you just do what you're supposed to do with this one to reduce that power of 4 to become smaller and smaller until you don't have any power of 4. You're using the squared identities with that one. But with this one, need to also look at identities and be able to reduce this power until it is not there anymore. And let me know when you have got a possible solution. Anyone with a possible solution? Any answers, please? Or is this one showing you flames? Okay, to save time, let's do it together then. Now, as I was saying, if the power is even, then it means that we will not have that luxury of splitting only one of this out. So we will be bound here to rewrite this as cosh squared x in brackets squared outside, so that we can be able to go and use this identity. This identity is coming from compound rules. So it says cosh squared x is equals to half into cosh 2x plus 1. Now we are going to replace the cosh squared in our integral with that one. So that cosh squared that we replaced is inside this square bracket, and it is squared again. This square that is coming again is the one that has been split from this power of 4 here. So when we split this from cosh power of 4x, it becomes cosh squared x, all of this power of 2. That is why now you still have a power of 2 outside, because what is inside this square bracket represents cosh squared x. Then now we do the normal multiplication of binomials, and we'll get 1 over 4, which means is the half squared, and we take it out. And what appears now inside becomes cosh squared 2x plus 2 cosh 2x plus 1. What we have here is found by saying cosh 2x times cos by itself, and it gives us that. Cosh 2x multiplied by 1 and 1 multiplied by cosh 2x. It gives us this 2 cosh 2x. And then 1 multiplied by 1 is 1. So this 1 over 4 is the one that is coming after half is squared. And that is what we get. Now again, same rule, very same rule. Cosh squared x is equals to half into cosh 2x plus 1. Now instead of x here, we have 2x. So this angle must again double if we are to employ the identity that is there on top. And in the next step, that is why you see that it's your half. Inside here, you get cosh of 4x now. Double this one plus 1. Now this is replacing the cosh squared x, and the rest of the things that are on the right side still remain as they are. Then what we can do now is to be able to isolate each and every one of these terms and write them with their own integral signs. So let's first talk about the first one, which is this one. This one will have this 1 over 4 multiplied by the 1 over 2, which will give us the 1 over 8. But now also with this one, we will need a 4 to be there for it to have the integral of 4 cosh of 4x, because the derivative of 4x is 4. So which means we will have the 1 over 8 that was there, and we will have brought in a 4. So we'll need to counter that 4 by a 1 over 4. So that 1 over 4 times 1 over 8 will become 1 over 32. That is why we are going to need rule number 17 for us to be able to do all these integrals. And what I was talking about, the 132, 1 over 32 is this one. Let me explain this again while you are seeing it properly. We've got this 1 over 2 multiplying this 1 over 4, and we get 1 over 8. But we've got a cosh 4x, which needs a 4 for it to be integrated. If you can go to your information booklet and check the rule number 17, you will realize that it has got a derivative of f of x sitting here, cosh of f of x. So because we need this 4, we're supposed to compensate this 4 by a 1 over 4. That's why you get this 1 over 32, because this is from 1 over 4 times 1 over 2 times another 1 over 4 that is compensating this one, and it becomes 1 over 32. Now, the next one is this one. Now, this one is also multiplied by this 1 over 4, which is the one that you see here. But already it has got a 2, which is the derivative of this 2x. That's why I just rewrote it in red. It does not need any compensation because it was there. Cosh 2x. So this is still the same rule number 17. And then this 9 over 8 is coming from this one. Now, how does this 9 over 8 come? Firstly, we will have a 1 over 4. Sorry about that. Multiplying 1 over 2 to become 1 over 8. This 1 over 8 multiplies this 1. And we get a 1 over 8. Now, a 1 over 8 is added to this 1. 1 over 8 plus 1 is the same as 1 over 8 plus 8 over 8. And when you add 8 over 8 and 1 over 8, you will take the denominator 8 and add 8 plus 1, which you get a 9. And this is where you get this 9 over 8. Then with the integral and dx, which is the one that is there at the end. And this one, we will use rule number 1 of integration, x to the power of 0. This is the same as the number 1 that sits here. So which will be x to the power of 0 plus 1 divided by the 0 plus 1. And hence, using rule number 17 on these two, you eventually get this as your final answer. 1 over 32 is the one that we bring down. The integral of cosh 4x is sin 4x. And then the integral of cosh 2x is also 1 over 4 sin of 2x. And then 9 over 8x, which is the one that we get by 0 plus 1. We on the exponent and divide by the result. Now, this one is the same as the one that we did previously in terms of that it contains two functions of x that are not related for now. But we have the rule that I have told you about, that I said there will be what we call not division by parts here. No, that is not gonna work. That is not gonna work here. This is simply straightforward from what I see now. It's simply straightforward and you can do it. Please try this one. It's a very straightforward integral. Just need your eye to be able to recognize something. As I have said at the beginning, your proficiency in finding derivatives is the key to solve this one. And it's very straightforward. So I will give you 2 minutes.
Sir, I think it's gonna be 1
Yes,
over
sir.
2. 1 over 2 ln sin e to the power 2x plus c.
1 over 2 ln of sin of e to the power of 2x plus c. Let's
sir.
hold on to that one and listen to others. Is there anyone who has got an alternative view to that one? And before this one, I will not want to explain before you, if you don't mind, so that you can explain how you found that answer from this very question that I said it's straightforward. If you don't mind, you can prepare yourself to explain a little bit before we show everybody what we have here, so that they can understand the thinking behind. So, but before you do that, let's get another alternative solution. Anybody with an alternative view? Can you please explain how you got that answer? Do you mind?
Yes, sir. Okay. By looking
Yes.
at the table, the formula sheet, number 19 there,
Yes.
you have, we have to get f prime of x. So the f of x is e to the power 2x. And then
Exactly. Can
f
you see?
prime,
Yes, absolutely. Then the derivative of
and
e to
then
the power of
f
2x.
is 2e to the power 2x. Then we have to compensate for the 2. Then we're going to say 1 over 2.
So what you have just mentioned now, is this. The derivative of e to the power of 2x is 2 e to the power of x. And only a person who understands derivatives will be able to connect this value inside the curve with this value outside. Because if you don't see that, then you will now start fumbling about these other rules that are very difficult. This question will come with 2 or 3 marks because of the simple steps that are needed. So what you just explained is what we have on the screen right now. The half that you mentioned is this one, and the 2e to the power of 2x in red resembles the derivative of the function f of x that is inside, which is e to the power of 2x. Now you can continue from here.
Then by looking at the table there on number 19, for that integration, we'll have ln sin e to the power 2x.
There you go. Rule number 19, you read straight from that rule, from this that you have on the screen, which is prepared. You prepared it perfectly and you rule it that the rule says, and the answer is that. And you nailed it so perfectly. That's how easy these things are. But there is no way in which you will be able to do this if you don't understand your derivatives. Because that connection is very crucial, that this e to the power of 2x outside is connected to the derivative of what is in here. Thank you so much, sir.
Pleasure, sir.
All right. Now, this one. Let's try this one. Also, this one is very straightforward. It's just that you need to be able to see things. Can you please, guys, try this one? Anyone with an answer? Ladies and gentlemen, anyone with an answer?
Yes, I believe it's going to be -1/2 sec square root of x plus c.
Listen how simple the final answer is. But look at the question itself. It looks very complicated. Is there anyone with an opposing view to the previous speaker?
So I got -2 sec square root x plus c.
-2 sec square root. So the only difference is that coefficient with the previous one, isn't it?
Yes, sir.
Okay, perfect. They are both correct. These answers are both correct. Let's get the third one. Until we prove that, hey, then you will see where you have gone wrong. But if you are not trying on your own and you wait for us to explain, I'm telling you, there's no learning there. Anyone with a third option?
Got the same answer as speaker 2.
Speaker 2, you are seconding speaker 2. So it means that we have got two views that are not that different. The difference is only the coefficient 2. So let's see actually what happens. So what you will do is you will go and check your rules. You will find rule number 22. In rule number 22, it looks like this. It says the integral of f prime x such f of x tan f of x is equal to something on the right hand side. So what you just need to do here is to look at your f of x. In our case here, our f of x is square root of x. The thing is now, what is its derivative? That's the key to this question. So the derivative of the square root of x is actually half x to the power of minus half. And they have provided for you that x to the power of minus half here at the bottom. This is the one. So it just only needs a half. Then it means to prepare this integral for you to be able to use rule number 22, you rewrite it like this. So you will have a 2 outside that compensates for the half inside that you need, because that half is found here in the derivative of the square root of x. So it must be there. Then you compensate it with the 2. Now x to the power of minus half is this one that was there already. So you just take this one up and it sits like that. Then you still have everything that you see on top sitting here. And you have got your dx. Now that rule number 22 is satisfied now because a derivative of the f of x is sitting there and such f of x times f of x is there. Then the 2 that was there must still go down. And I didn't. So which means I have got it wrong myself. And the correct answer was supposed to be -2 sec of square root of x plus c. So the other person who have got it like this, you did it, you made the same mistake as I did. The correct answer is the one that does have a -2 there. Do you guys agree?
Yes, sir, we agree.
Perfect. So I have modified mine to look like the correct option that was given there by someone. And we will, so I just want to check my slides so that we finish. We're left with 3 from this one. So we're still on time. We're still very much on time. Now a little twist has just happened on that question. Can you see the difference between the previous question and this one is that power 2 on such squared, on such square root of x, the square that is there. In the previous one, it was just such square root of x times square root of x all over square root of x. Can you attempt this one? And you will now appreciate the power of the exponent. So when it comes, it changes everything. Please attempt this one. Anyone with an answer? I once again will repeat. For you to be able to be proficient with integration, you need to master derivatives. Anyone with an answer? Guys, any answer? If you are quiet, it means that you are struggling. Shall we look at it together? Or is there anyone with an answer now? Okay, let's do it together. Right, now, if you remember that my slogan, master your derivatives, master your derivatives. Now, if you remember in derivatives, derivative of tan in trigonometry is sec squared. So the derivative of tan, if you go to it now, you will find that it is also sec squared. So which means now in this case, your candidate for being f of x is this tan of square root of x. And then the rest of these things should be the derivative or connected to the derivative of tan of square root of x. So we will let f of x be tan of square root of x, find its derivative. And the derivative of this will be the derivative of what is inside first, which is half x to the power of minus half, which is this part, such squared, square root of x. Now you can see all of this is covered here, except only the half. So we only need a half. So to prepare this for rule number 3, that is rule number 3 that we will be using here. Then we will have our derivative that is there in red. The such square root of x was the provided. The x to the power of minus half is this one when you take it up, which is that. The half is the one that you see here, and we need to compensate it by putting a 2 outside. And this is ready for rule number 3. Tan of square root of x is our f of x is power 1. So it means that we'll just add 1 and divide by the result. And the answer is this one. And the answer is that one. Tan squared square root of x plus c. But
So
only, yes.
what happened to the 2?
So this 2, right? So
Yes.
when we do an integration of this f of x, that is raised to the power of 1. Again, we will add 1 to 1 and we'll get a power 2, which is this one, and divide by the result, which is 2. So the actual integral will be tan squared square root of x all over 2. But then there is this 2 that is outside that divides the other 2, and we get it like that.
Okay.
Does it make sense?
Yes.
Absolutely. Then let's do the second from last.
Sorry, sir.
Should I go
sir.
back?
Can you go? Yes, please.
Yes.
Here, sir, most you're integrating tan square root of x. And we have it on
Yes, that is the one that we are integrating.
we have it on the table there.
Come again?
We have it on the table there.
Is there on the
rule
table?
number 18. Yes, number 18.
Rule number?
18.
Now, rule number 18, if you check it properly, yes. What sits here in rule number 18 is the derivative of the square root of x only. It's not the derivative of the whole of this thing. Can you check that rule properly?
Now,
What
yes,
sits
okay,
here
now I
is
see.
only the derivative of that.
Yeah, of tan. Okay, now I get it. Yes.
Yes.
I
Now,
get it.
in this
Thank you.
case, yes, in this case, what we have here in this big bracket is the derivative of everything, of the whole of tan square root of x.
Yes.
Thanks for the question. It's a very good question, that one. Okay, shall we move to the next one, which is this one? Can you do this one? This is the second from last, I hope. Yes, it is. The second question from the last one. Can you kindly sort this one out quickly? Anyone with an answer? Because this question looks a little bit complicated, but it is not.
Hi, sir. Sorry, I'm a little
Yes.
bit behind on the chapter, but I just want to confirm if that cos to the power 4x minus sine to the power 4x, is that not an identity?
It is not. The identities only have powers of 2. So with this
Okay.
one, I think your question can be answered this way. You can create an identity from what you have.
Okay. Thank you.
Does that give you an idea?
I think so. Honestly, I
Yes.
I am very far behind, but
No, you
I
are
will
you are
catch up.
not. If you are thinking along those lines, it means you are ahead. Because
That's
think
nice.
of identities. How do they look like? They look like they are having powers of 2. From this, can't you create a situation where you have powers of 2? If the answer is
Absolutely.
yes, do it.
Yes, from the
Do
difference
that.
of two squares. Yeah. Thank you.
Viva, there you go. Perfect. Just use that difference between 2 squares and factorize. And then after that, you will see your identities coming flying there. You will see them properly. And you apply them. And this becomes very, very short. And then it goes to a very simple answer. Anyone with an answer? Anyone with an answer? The key to solve this question is about identities only. The hint that was given by the previous speaker, this is the difference between 2 squares, and you factorize this one. From there, identities apply, and you get this answer straightforward. The first step will be this one. So if you can try and rewrite cos power 4 of x, s cosh squared x squared. And you do the same with sin. Then when you factorize that difference between two squares, you get what you have there on the screen. Now, when you go to identities, there's an identity exactly for this.
Which is 1.
And there is this one, the first one. What is the
Yes.
identity for the first bracket?
It's 1. Oh, no, not 1. The other one. Oh, yeah.
For the first bracket, it's not.
Yeah.
Remember,
That
this
one
one
is
are not
cosh.
twigs.
It's cosh 2x.
This one is cosh 2x, and this one?
It's 1.
It's 1, exactly. So you use this identity that says cosh squared x plus sin squared x is cosh 2x, and the other one says cosh squared x minus sin squared x is 1. When you replace those there, you only get this one. And it only misses the derivative of 2x. So the derivative of 2x, rule number 17, if you go and check it, it says the integral of f prime of cosh f of x. So we need that derivative to be there, and that derivative is 2, and we are compensated with a half. And from number 17, voila, the answer is half sin of 2x.
Jesus Christ.
Sorry, which is this one? Half sin of 2x plus c. That's how easy this thing is. But as long as now you manage to be able to identify the kind of identities you need to use, and the key here is about factorizing this, rewriting this as cos squared all squared, sin squared all squared, and then you factorize and you get something like that. So shall we move to the last one, which is this one? Also, now this one will need that method that I talked before, but for now we can work without using that method, the method of integration by parts. Integration by parts can be used to solve this one. Maybe when we deal with that section, we will take these questions and use them and check if the answers that we will get will be the same as what we have in this slide. But for now, you can work with something else without doing integration by parts. So can you find what is it that you can do to this one to solve it without integration by parts, so that we don't waste your time? I would think that, let me give you a hint. The hint is to rewrite your integral like that, and you will know that there is that identity. Now use this identity, put it in here in place of cosh x, and give me the final answer after you have done integration. So this one, it's a little bit, it needs a little bit of focus. So I will give you 3 minutes for you to continue from here. Anyone with an answer? I hope after this you had something like that. And where do we go from here?
I ended up with e to the power of 2x plus 2x plus c.
The final answer is?
I had e to the
Come again?
2x, e to the power of 2x plus 2x plus c.
E to the power of 2x plus 2x plus c. That's the first answer. Anybody with a different answer? We had the first answer, e to the power 2x plus x plus c.
I second that one, sir.
You second that one?
Yes, sir.
Okay. So they seconded, and is there no opposition? Anyone with a different answer? Do you guys who are seconding each other, do you have this step that you see on the screen?
Yes, sir.
You have this step. Okay. If we don't have any other alternative, so let's see how I did it and see if it converges with the option that was there and seconded. So so if you look at this question and you look at the denominator, which is the candidate of being f of x for now, if you take that as f of x and you find its derivative will be e to the power of x minus e to the power of minus x, which does not connect with what we have there in the numerator. So that option will not work. If it was the other way around, if this was a reciprocal of what we see here, it's just a matter of dividing e to the power of x on each one of the numerators. But when it is like this, you cannot divide here. So I actually took out a common factor. there are two possible common factors that we can take out here. Let's say somebody wants to take out this as a common factor. This one, e to the power of x, out as a common factor. Then here you will have a 1, and here you will have an e to the power of minus 2x. Then that e to the power of x, that is a common factor outside, cancels with this one, and you will have 1 over 1 plus e to the power minus 2x. And you get stuck because the denominator that you have, you will not be able to find its derivative connected to 1 that is there on top. And the only option will be to take out e to the power of minus x as a common factor, which when we do that, we get something like that. So we take this one out, it sits here, and it divides into this one, and we get e to the power of 2x. It divides into this one, we get a 1. Now, when we take this e to the power of x up, we get e to the power of 2x all over e to the power of 2x plus 1. And as I said, mastering your derivatives now entails the fact that when you find the derivative of the denominator, e to the power of 2x plus 1, the derivative is 2 e to the power of 2x. So which means that rule number 3 here will work, because we'll just take this 2 that was outside, put it inside here, and what is sitting here on top is the derivative of what is sitting here at the bottom. Which means, because of that, rule number 3 says, because this is power of minus 1, the whole of this is power of minus 1, the answer is this one, which is different from what the two gentlemen has agreed on. And I am not saying that mine is correct and theirs is wrong. So what I want us to do is, for the two gentlemen, one of you guys, can you please start us from here? In fact, let's do it this way so that I can be able to write. And let's just first confirm that this is the last slide, so that I don't go out here and we haven't. Okay, yes, this is the last one. So what I'm doing here is I am going to copy this integral where it is now, which is the second step or a third step. And I will want the two guys, one of you guys, to explain to us how you reached that answer. You may find that the two answers are both correct, unless you are deciding to go with my answer before we go to the new page where we can write. Are you still confident with your answers?
I'll explain how I got there, but I'm not sure if it's correct.
Okay, that's very good. So I want that. So let me get out here. Let me just first copy this and take it to a place where we can write what they have to say, to see when they reach the answer, whether we agree with that answer or we don't. And I think that will be the last bit for today. And I think we are ending exactly at 8. So let me come here and get a, okay, here's the new Microsoft Word. No, this one has got a lot of other things. Let me just open a new one. All right, there you go. Okay, so let it chill a little bit. Oh, it is not able to paste. Copy. And paste. There you go. Let's make it a little bit bigger. All right, so let's start from here. Guys, what is your next step from this one?
Okay, so from there I took the denominator and brought it on top to the numerator to the power of -1, and then I multiplied it out.
What? Okay, let me go undo. Hey, where is undo here? So this does not have undo.
Control
You can
Z.
do Control Z.
Control what?
Z.
Z. Okay. So you are saying we go to this. So let me go and do my pen now. And I'm doing what you are just saying. Where is the pen? Draw, ne? Yes. Draw. Yeah. So what he just mentioned is that he will take this one up and write and everything power of -1, right?
Yeah, correct.
Correct. So which means I shouldn't have brought the pen now. This thing here, pen is okay, there you go. So let me just do it quickly. What you just said now. So it means that we are deleting the e to the power x, this one, and this one goes up here. It becomes plus e power minus x. And all of these are raised to the power of -1. So it's that. And sorry, that power -1. Is this what you are saying?
Yeah, but I had the e to the power of x on the top as well, so I got rid of the denominator. So I basically
How did
brought
you
the
do it?
denominator. I was trying to simplify.
No. But for now, these two statements are equal. The ones that we have. This and this are the same. This is the same as that. When
Yes,
when you have a power of -1, it means that when you apply the power of -1 inside, it changes this into that. So now I want you to tell me the next step after this one.
Yeah, I think I found my mistake there because I see that's the reciprocal, but I wasn't trying to match it. I was trying to simplify the integral before getting to that point. So I didn't get to this point where you are now.
Okay. But these two statements are exactly the same.
Yeah.
Then what I wanted to find out is how did this -1 get inside here? Because
So
there is no way in which it will get inside onto these two because there's of the plus sign in between. Okay. So which means what we have done there, you are agreeing that there's something wrong you did.
Yeah, so I ended up multiplying the -1 and it just changes the signs on each, but it ends up being the same. And I ended up with a e to the power of 0, which became 1, and then that became the 2x.
You can't do that.
Yeah.
Because of the plus sign. So the other guy, did you do the same as the seconder? There's a seconder there who said he's seconding your answer. Are you still seconding? Or you are withdrawing? You see, he's throwing you under the bus. He's not saying anything anymore. Guys, thank you very much for tonight. We are done for the day. And next week, Thursday, same time, we will be doing Unit 5. Have a wonderful evening. Can you please all go out of the meeting before we close it so that the recording can be saved?
Sir,
Bye-bye.
before we close, I have a
Yes.
suggestion, sir. Can we please change the way we do our classes? Like, can you please go through the example first, and then you allow us to do the questions that you would have prepared, because some of us we will be lost or like on which topic we are doing. So can you please go with us step by step, analyzing each and every example that we have like on the study guide, because it will make it easier for us to engage more, because like I've been listening and it's only like three guys who are like answering, and then some of us we are just watching, you see. So I would like to like engage more, So that's the only way that I can engage more, because that was the same method that was used by our previous teacher.
Come again?
I'm saying I would like you to go through example first before allowing us to attempt your questions, so that it will be easier for more of us to engage with you as you go through the examples and the questions, so that we know where we are.
Yeah, so my question to you is, do you want me to do an example that is done in the study guide and bring it here and explain it? Then after
Yes,
explaining it, then I let you, and we continue as we have been doing.
yes, sir.
But the example that is done in the book, you can go through that yourself. And this lesson today is for this way of doing the lesson is for the first time I'm doing it like this, because I have realized that the hyperbolic functions work in the same manner as the trig functions. Were you there in the previous lesson, my brother?
Yes, sir.
The
I
lesson
was there.
on trig.
I was answering there.
So if you were there in the previous one, have you seen the resemblance of the way in which we are answering questions in hyperbolic and the trigonometry?
Yes, I've seen, but it's just that I haven't started with the topic. So I am speaking on behalf of those that haven't attempted the topic, because I think this way it favors those who are ahead more than those who are behind, because they will be lost, like in which identities to use, the rules to use and all that.
Oh, okay. So you know, here I'm trying to make everybody accommodated. But then it will be difficult for me to go and do an example that is in the study guide as it is, and I copy and come here and present it. I mean, I don't think it will be worthwhile for me to do it, because you can go and read it on your own. That is number one. Number two, when you say that other guys are ahead, what is stopping you from doing the same thing as these other guys? Because what we expect you to do, these lessons are just helping you to be able to connect the dots of things that you have already. So I cannot be expected to come here and teach you everything from scratch, like you are seeing it for the very first time. I'm helping you understand things that you have gone through already. That is what I'm hoping it's happening. But if I will be going to unit 4, for example, that like we did today, and you are seeing this unit 4 for the very first time with this presentation, then it means that everything that we are doing is wrong. Because in my thought, I would think that you would have gone through unit 4, and when we come here, we're consolidating whatever you have studied on your own. I understand that there may be somebody out there, I'm not saying accusing you, but there may be somebody out there who is hearing about integrals of hyperbolic functions for the first time in this lesson. That is not the intention of these lessons, unless maybe I've got a wrong brief from the lecturer.
The one of the reasons that I am suggesting this, it is because the lecturer too used the same method, and we were quite engaging with her, and it was faster that way. But it does not have to be an example that is on the study guide, but you can bring your own type of questions, and then you can go through it step by step, and then you allow us to answer just like we were doing, like right now. You like allow us to answer, and then you come after that. It's
Yes,
just an
and I would
efficiency
think,
there.
yes, I understand where you're coming from. I think if you remember the very first lesson, if you were there, I didn't give you any opportunity to do anything. I was the only one speaking and doing these things, and somebody suggested that you must participate. And in the second lesson, I would do one step and ask you to do the next step and so on. It was the trigonometric integrals. And this one, I thought because this one is very closely related to trigonometry, then I should let you guys do them. So let me sit down with Dr. Dlamini and we can find a way so that we can be able to accommodate you and those guys that you said are ahead. If in the next lesson we are not able to do that, please do not keep quiet. Say it again if you feel not accommodated. But I would like any other person that is here to tell me if they are supporting the previous speaker or if they've got another way of seeing these things, because I'm the one here who is supposed to be listening to you more than you listening to me. So we get any other person who is not the person that I was talking to, any other person to just get in and maybe give us a direction?
Yes, sir. Okay, carry on.
Yes. Yes, we can hear you. Tabanene.
Yes, I second him, sir. Like, for example, just do one example just to let in the guys on the introduction of that unit. Then the following, then we can carry on and engaging us.
Okay. So
Yes,
what
sir.
I did in the very first lesson, throughout that lesson, I was doing all all these activities by myself. I must just do one, and then give you next for you to do the way we were doing today.
Yes.
Yes,
So
sir.
No,
so
sir.
that's what.
I think they mean that you do one example from the study guide and explain it, and then after explaining, you can then come with the questions that you are busy giving us, so that we can work through them like you did today, so that everybody understands the concept more. Because we are similar with what's in the study guide more than anything. So if you do an example from the study guide and work through us that particular example, then I think he says it will then become easier for us to do the other examples, because we have an idea. Or sometimes you are alone, you do it, but you don't have an idea, you are lost somewhere. But if you explain the concept there for just one an example, then it will be easier for us to also participate.
Okay. So if that is the case, then I am on the study guide number 2. Is it possible for you to go and pick maybe one example in unit 5 that we are going to do next week, for me to present it first, and then the rest of the questions will be done the way we were doing today? I don't mind doing that if that is what you want, because this is supposed to benefit you more than I am. I would comply and do what you are saying. So I'm scrolling down to the beginning of unit 5. Here is unit 5. Perfect. So unit 5 is about the integrals of this type. So is it possible for you guys to maybe pick one example that is here that you want me to do for you the way it's done here, and then explain it in detail? So here we've got example 1 and 2. Example 1 is this one, right? And then we have got example 2, which is this one. We have got example 3, which is this one. We have got example 4, which is this one. Example 5, which is this one. Example 6, which is this one. And yeah, pick one example from the 6, and then I will do that one. And I think to make our life easier, I should even refrain from bringing my own questions, and we go and do these questions that are here in the guide, so that you guys, then I will put up this one, and you guys do as I was doing in the previous example, and then we do the rest of the ones that are here, and we go on like that. Is that what you want?
No, I
Sir,
think
no, it's
maybe if
also good.
you half and half, because now we need to get
Yes.
challenged as well. We can't do things from the study guide only. It's okay what you're doing, bringing other questions. We don't mind other questions.
Okay, but okay, then
Because you're
choose one
preparing us
example
for the
from the
exam.
6 then. Okay, so we can have that example that is in the book and I explain it. After doing that, then I give whatever activities for you to do and we go through the way we did today. So that is the modus operandi from now going forward. I will do that. So I want you guys to pick one example from 1 up to 6 for me to do with you first when we meet next week, Thursday.
Sorry, sir, if I may just add something on that. Perhaps
Yes.
it might be helpful if maybe like we all have like a study guide and maybe have like the page that has the formulas or the standards, if I may say. So that when you refer to rule number 17, we all look at rule 17 and then I think we'll have a better understanding of what is being discussed. Because if you just say, if you're gonna say, for instance, we're using rule 17, for somebody like me that has never opened the book and I'm just looking at the rule as you scribble it down, but I actually never send the rule. It just becomes difficult. I think everybody needs to like have the study guide at hand whilst we go through this discussion, so that if we all refer to rule 17, we see what is on rule 17. We see the first derivative, the integration of the first derivative of f at x, which is cosh f at x times d at x. And then maybe the explanation should be somewhere around there. I think maybe people will understand better.
But you are just saying to me that you want me to spoon feed you
No, not
no. Let me finish. Let me finish. You said that if you mean you don't have at the beginning first lesson. I said when we do these lessons going forward, always. I think I will write this when I do the announcements. Ne? You must have all this the document that has got formulas. When I say formula number 17, you should be able to be seeing it. I mean, this I shouldn't be telling you that you must have it. That is
no,
not we cannot even discuss about that part.
no.
So if I will say rule number 17 and you don't know which rule I'm talking about, that you cannot blame it on me. Never
No,
ever.
the,
So what I'm saying in short, you must have everybody to come to the lesson. You must have all these rules where you can see them. When we quote, you know what I'm talking about. Sometimes I copy them and I show them on the screen, but it is not always because I think that everybody has got these rules.
I totally understand, sir. Hence, I'm saying for this, my comment is specifically on the students to say we need to have the tables. So when you say maybe let's look
Oh,
at
thank you.
refer to rule 17, so somebody knows where we are. And then when you explain, it just becomes easier to say, oh, this is because we integrate, we derive this and that and that. It's better to understand when you actually have the formulas at hand.
100%. I thought you are saying that I must provide. So yeah, if that is the case, you are right. And another thing that I can add on to what you just said is that um, uh, uh, if you are coming to these lessons and you have never, like now you are going to Unit 5 and you are going to be hearing about what is going on in Unit 5 for the very first time next week, Thursday, then I have a problem with that. I have a huge problem with that. Because our lessons are not to teach you these basics of like we have got these rules, this rule number 1, how it looks like and everything. I actually explained rule number 2 and rule number 3 because we use them often everywhere, but I don't go around explaining to you rule number 17, that the integral of f prime x cosh what is minus what on the right hand, because what I thought was happening was that every one of you has got those rules next to you when we are doing these lessons. That was my assumption. And I will take the blame that I shouldn't have assumed that. But I have said it at the beginning that you need this document to be with you, because what we are trying to do with you here is to show you how you can get all these answers correct, because you have got the answers with you in the examination room. That's what I said from the onset. So from now going forward, I will do the thing of the example. So should I just pick any example amongst those 6 and explain it, because I asked you to pick one and you're not? There are 6 examples in Unit 5. There are first 6 examples there. Or else, if you can communicate with Doc during between now and say Monday, and tell her which example you want me to explain, then I will do that example, explain it properly with no interference from you guys, and then at the end, then I will pop up the questions that we'll be doing the way you are suggesting. I don't have any problem with that. Any example that you are thinking of now, or are you gonna give Doc the example by Monday, and then I will do that example for you?
So I think it's fine if you pick it. If you can pick any example, I think it's fine.
If I can pick any example.
Yes, sir.
Perfect. I will do that. I will do that. Then I will, from now going forward, I will work like you are saying, pick an example that is existing in the study guide, do it, explain all the details, and then from there, we attack questions that are exam type questions, and we go to the next unit until we finish. Oh, I'm happy with that. Bye-bye. Everybody, go.
Cheers.
Thank you, sir. Bye.
Okay. All right. Bye-bye. Moikanyeng, please go. Tulile. Bye-bye. Tulufelo. Tulile. Please go.